Now see this question. In this question we have to find the equivalent resistance between terminal A and B. So here this is circuit. Now we will solve this question by a special method. Okay. Suppose here voltage is V. Okay. And current here is I. Okay. Suppose we assume current here, that is A. Now when this is current I and this is current A, now what is current in this branch? Okay, so what is current in this branch? That is equals to I minus A. Okay, so when here current is I minus A and suppose here current is B in this direction, we can assume any direction of current. Okay, and according to the assumed direction we can find the distribution of current in each and every branch. So here suppose current direction is B and we assume suppose current direction is here like this. So what is current here? That is equals to I minus A minus this current B. Okay, now we make the current distribution in each and every branch of this circuit. Now after this we can write equivalent resistance Req, that is equals to V upon I. So here we have to simply find the value of V upon I. First apply KVL in this loop. Okay, so we are going to apply KVL in this loop. So when we apply KVL in this loop, we get, suppose we are moving here. Okay, sorry, suppose we are moving in this direction. Okay, so first this minus A is encountered, so minus A into 1 plus I minus A into 3. Okay, and then plus 3 into I minus A minus B. From this equation we get 7A plus 3B is equals to 6I. So this is our first equation. Okay. Now take the second equation. Now we will apply KVL in this loop. Okay, now we will apply KVL in this loop and we will move in this direction. Okay, so apply KVL, we get the current in this branch. What is current in this branch? That is equals to this A and this A will cancel out, so simply I minus B is the current here. Okay, so 3 into I minus B minus 3B plus 3 I minus A minus B. Okay, so on solving this we get A plus 3B is equals to 2I. So this is our second equation. So when you solve these two equations, then we will get A is equals to 4 by 9I. Sorry, B is equals to 4 by 9I and A is equals to 4 by 6I. Now apply KVL in this loop. So when we apply KVL in this loop, we get VAB, okay, that is voltage V, that is equals to voltage V is equals to A into 1 minus 3, this is minus 3 because this current is in opposite direction, minus 3i minus a minus b plus 3b. So in this equation, if we put the value of a is equals to 4 by 6i and this a is equals to 4 by 6i and put this b is equals to 4 by 9i. So when we put this, we will get V upon I is equals to 7 by 3 ohm. It means equivalent resistance Req is equals to 7 by 3 ohm. So this is the answer. Now see this question. In this question, we have to find the equivalent capacitance of this circuit. We know that when two capacitors are in parallel, okay, this is C1, this is C2, then equivalent capacitance is equals to C1 plus C2. When two capacitors are in series, then equivalent capacitance 1 upon equivalent capacitance is equals to 1 upon C1 plus 1 upon C2. Okay, so the method of finding equivalent capacitance is just opposite to that of finding equivalent resistance. Now see this circuit. In this circuit, we can clearly see that this point and this point are at same potential. Suppose these are at potential B and this is at potential A and this is at potential suppose C. So we can see that suppose this is point A and this is point B. Now this 2.5 microfarad capacitor is connected between point A and this B because this is also B. So we can draw this first this 2.5. Okay. Now suppose this is point C. We see that this 1.5 farad microfarad is connected between A and C. So we connect 1.5 microfarad here. Then we see that this 2 microfarad is connected between C and B. So we will connect it as like this. Okay. And we see that this 1 microfarad is again connected between C and B. So again we connect this 1 microfarad. Okay. So now we can easily find the equivalent capacitance. What is equivalent capacitance? That is equals to, suppose this is parallel combination. So equivalent capacitance of this parallel combination is simply equals to, suppose this is C1, that is equals to 2 plus 1, that is equals to 3 microfarad. Okay. Now this 3 microfarad and this 1 microfarad are in series. Okay. So when they are in series, then we can simply find the equivalent capacitance as this 1.5 into 3 upon 1.5 plus 3. Now this whole combination is in parallel with this 2.5 microfarad capacitor. So in parallel they simply add. So we add plus 2.5. So our answer is 3.5 microfarad. Okay. So this is the answer of this question.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.